In this video, we are going to look at example 3 of section 4.2 and 4.3 on the Riemann sums and definite integrals. So in this example, we're asked to use a middle sum with 4 rectangles to estimate the value of the integral from 0 to 16 of sine of x squared over 40. We're told a graph of this function is shown on the right. All right, so first let's just draw out what it is we're going to approximate or estimate. So we're looking, this integral here from 0 to 16 tells us that we're looking to estimate the area under the curve from 0 to 16. We are told that we want to use a middle sum. So this means the height of the rectangle we use is the function on the midpoint of the rectangle. So let's draw this out and then we'll compute those areas. So we're using 4 rectangles and we're going from 0 to 16. So we have 16 units we need to cover. Divided into 4 rectangles is going to give us 4 units of width per rectangle. So we can draw those in. So I'm just going to draw in those widths. And then we'll use the middle value of these intervals to compute the height of the rectangles. All right, so the middle value will occur from, well, we have 0 to 4, so the middle value will be here at 2. 4 to 8, the middle value will be 6. 8 to 12, the middle value will be 10. 12 to 16, the middle value will be 14. So then we need to compute the function value at that midpoint. So let's first just draw those in. So we have our function value here. So that will be the height of this rectangle. We have a function value up here. That will be the next height. And our function value here. This will be the next height. And then function value down here at 14. That will be the next height. So then these areas of the rectangle are what we need to compute that middle sum. So now let's write out, so we are estimating the integral from 0 to 16 of sine of x squared over 40 dx. That estimate is going to be obtained in this example by computing the sum of the area of these rectangles. So to compute that area, those areas, we need to multiply the height by the width. So the first rectangle, the height occurs at f of 2 and the width is 4. The next rectangle, the height is evaluated at f of 6 with the width of 4. The next rectangle, the height is f of 10, width of 4. And the final rectangle, the height is f of 14 and the width of 4. So I haven't put anything here yet because I want to make an important point. So notice how the first 3 rectangles, the heights are all above the axis. So we consider these areas positive. Now, whenever our height is below the axis, that is considered a negative area. So we're going to subtract that area of the final rectangle. This is also the case once we get into more and more rectangles. So for example, if we're looking at a smooth curve like this, and we want to know this area, we consider the area below the x-axis as negative area. So we'll see more of that in future videos, but this is something to keep in mind. All right, so what we can do now is factor out the width of 4 and then compute the function values. So f of 2, we get sine of 2 squared over 40 plus sine of 6 squared over 40 plus sine of 10 squared over 40 plus sine of 14 squared over 40. All right, so now we can go over to our calculator and compute these sine values. So please pause the video and work it out on your own. And then in a minute, we can check our work. All right, so here we're getting 0.0998. The next term, sine of x squared over 40, we're getting 0.7833 plus 0.5985 minus 0.9825. Something I just want to step back on a little bit, f of negative 14, notice is a negative value already. So I actually didn't have to include the negative. I'm going to add this term. But when I compute the value, what's important is that that term becomes negative, which makes sense because we want to subtract the area under the curve. All right, so just keep that in mind. We don't have to artificially input a negative here, but I just wanted to point out that that value should be giving us a negative area, which it in fact does. Okay, so now when we add all those together, we get approximately 1.997. All right, so then our estimate for the definite integral from 0 to 16 of sine of x squared over 40 dx is 1.997.